Hi everybody, how are we doing today? Today what we're going to be talking about is we're going to be graphing systems of equations. So we talked about what a system of equations is. Now we're going to take systems of equations and we're going to put them on graphs so that we can understand them better. But first, I want to tell you about a couple of people I know. This is Xavier, or as he likes to be called, Xavier. This is Yancey. Xavier and Yancey are friends. And they're friends because they share an important hobby. Their hobby is they like to collect 1970s era Chevy El Caminos. Yes, it's an amazing feat of automotive ingenuity, the El Camino is. They're beautiful crafts. And Xavier and Yancey love them. So they get together and they talk about their El Caminos, and they wash their El Caminos, and they drive their El Caminos around. And here's the deal with Xavier and Yancey and their El Caminos. If X is the number of El Caminos that Xavier owns, and Y is the number of El Caminos that Yancey owns, together they own a total of 4 El Caminos. But I'll tell you this. Yancey owns 3 times as many El Caminos as Xavier does. Alright, so now, if I told you that together they own 4 and Yancey owns 3 times as many as Xavier, we now have a system of equations. There are 2 equations with 2 variables each, and we can use the 2 equations together to help figure out what x equals and what y equals. Now, if you look at these 2 equations, and if you realize that there's a total of 4 cars, you could probably figure out that the solution to this problem is that Xavier owns 1 and Yancey owns 3. Not too difficult to figure that out. You could probably figure that out in your head. But what if you had a system of equations that you can't figure out in your head? Then what you would have to do is use what's called the graphing method. The graphing method relies on you remembering slope-intercept form, y equals mx plus b, where m is the slope of a line and b is the y-intercept of a line. So let's say we take y equals 3x. What's the slope of that? That would be 3. What would the y-intercept of this be? Well, there's nothing there, so I guess it would be like 3x plus 0, right? So 0 is the y-intercept. So if I graphed this, I would start at 0, because that's my y-intercept, and then I would count my slope of 3, which is like up 3, but it's like 3 over 1, right? 3 over 1, up 3 over 1, put another dot, boom, y equals 3x. I've got it graphed. Now what I need to do is take the other equation, x plus y equals 4, and I need to graph that on the same graph. But first, I have to get this in slope-intercept form. So I've got to get the y by itself. I've got to subtract x to the other side. Now I can see that the slope is the part in front of the x. It's like a -1, right? And then the y-intercept is 4. You got it. Okay, so now if I graph this, and I'll do it in green, what I'm going to have is a line that goes like that, because it hits the y-axis at 4, and then the slope is -1. It means it goes downhill. It goes down 1 over 1, down 1 over 1, down 1 over 1. What I want you to notice after all that work is that the solution, which we already knew, happens to also be the point at which these 2 lines cross each other. Well, how do you do? The solution to a system of equations is in fact always the point where the 2 lines cross on a graph. That wasn't just a coincidence. It wasn't just happenstance. It happened that way for a reason. We can solve a system of equations just by graphing the 2 equations and seeing where they intersect. So if you have a system of equations that you can't figure out in your head, or by guessing and checking and guessing and checking, you can solve the system by graphing the 2 lines and seeing where they cross. So we can solve a system of equations just by graphing the 2 equations and seeing where they intersect. How do we solve a system of equations? You graph the 2 equations and see where they crisscross each other. Okay, once we know that, then we can solve any system of equations. So let's say you have y equals 1/2 x minus 1 and y equals -x plus 2, and we don't want to try to guess and check and guess and check and guess and check on this. We are going to try to graph this thing. So here's what we're going to do. Whoops, what happened there? There we go. We're going to solve it by graphing. And I'm going to graph this one first right here, and I'm going to solve it, or graph it, by figuring out that the slope equals 1/2. So I'm going to put a, wait, no, I'm not going to put a dot there. I'm going to put a dot there because the b, the y-intercept, is -1. I'm going to put a dot right here at -1. And then I'm going to count the slope up 1 over 2. So up 1 over 2, put another dot there. Up 1 over 2, put another dot there. And my line would go kind of like that. Okay, now I'm going to graph the other one, this one. What's my slope? My slope is -1, which is like -1 over 1. And what's my y-intercept? 2. So I'm going to start at 2, put a dot, and then I'm going to go down 1 over 1. Okay, down 1 over 1, put a dot. Down 1 over 1, put a dot. Oh, look, they crossed right here. So what's the solution to this system of equations? The solution is the coordinates of that point. And the coordinates of that point are 2, 0. And that is my solution to this system of equations. And you can check and see if that works by taking that solution and plugging it in here to see if you can plug a 2 in for x and a 0 in for y, and plugging in here and seeing if you can plug a 2 in for x and a 0 in for y. I'll let you check that on your own. You can just trust me. It works.